Okay, so when trying to determine the degrees of freedom and the p-value, when comparing two population means, just watch out for those degrees of freedom. Okay, from before we said that the degrees of freedom when the sample variances are pooled is n sub 1 plus n sub 2 subtracted by 2. Okay, in this problem, population variances are not equal, so that means we need to use the smaller of the two degrees of freedom. Okay, so we got a sample size of 15, a sample size of 13. That means you're going to use the sample size of 13 to determine your degrees of freedom. Okay, so the degrees of freedom from this should be 12. Okay, so the p-value part can be a little tricky if you had trouble with p-values before. Um, Reading the table is actually pretty straightforward, but it also depends on your null and alternative hypotheses. Okay, so degrees of freedom of 12 means we use this row that I've highlighted. We have our test statistic here of 2.45. So 2.45 is between 2.179 and 2.681. So that means our p-value is between 0.01, this number up here, and I'm rewriting it. The order is different because we're trying to write it least to greatest. It's between 0.01 and 0.025. Okay? And that's it. That's our p-value coming straight from the table. But remember, the tables that Newton gives you are tables that only tell you the area to the left. Okay, so it's one-tailed area. If this alternative hypothesis said mu1 doesn't equal mu2, then that's different. You have to double each p-value, okay? The area of the p-value is doubled. So you'd have to do 0.02 is less than the p-value, which is less than 0.05, okay, because it's two-tailed. But this is a one-tailed test. That's why we can just take the numbers straight from the table. So just watch out for that. If you have a two-tailed test, if it says does not equal, it means you have to double your p-value.